The calorimeter was calibrated in this example with 1 gram of benzoic acid. And it has created a temperature increase of 3.4, 3.5 Kelvin. So the calibration is a 1-point calibration.
1-point calibration.
With 1 gram benzoic acid at 3.4, 3.5 Kelvin temperature increase. So ideally, my sample will create the same temperature increase as 1 gram benzoic acid. And the problem is, normally this is very difficult. How can you know how much sample weight you need to get the same temperature increase? You cannot know, because the sample result is unknown. When it's some cold sample, how do you know that it will be exactly that much to create a temperature increase of 3.4, 3.5 Kelvin? So theoretically you would have to make a pretest to see how much gram you need to get a temperature increase of 3.4 Kelvin. So, but that's not practical. So the standards have given a so-called range of linearity for the calorimeter, meaning the calorimeter has to give a proper result within 30% plus minus of the calibration at a temperature increase of 3.4, 3.5 Kelvin. So if the energy is 30% higher or 30% lower, then the result must still be good. But let's say you calibrate with 1 gram benzoic acid and then you burn your sample and you have created 3 Kelvin temperature increase, and your temperature increase with the sample was only 1 Kelvin. Then it's too little, because you calibrated at 3 Kelvin.
All right.
And you have plus minus 30%. This is the valid range. But you only get 1 Kelvin. So you need to burn more sample material to get the same temperature increase as with the calibration. If your temperature increase is too low, you are out of the linearity range of the calorimeter. So here's an example. Here we have checked the linearity range. We have burned 0.75 gram and 1.25 gram and 1 gram of benzoic acid. And you see, if I burn 0.7 gram, I get the same result as if I burn only or more than 0.7, I burn 1.25 gram. All the results are distributing around the average or the reference value. So with this check, by burning different amounts of benzoic acid, not as a calibration but as an actual test, I have changed my temperature window not only for 3.5 Kelvin but also for 2.5 and 4.5. So now I burn my sample and the temperature increase must be within this range. And if it's not in this range, then I have to either burn more sample material or I have to add something that spikes the energy higher to be in this range. And that's why you have a deviation. If the temperature increase is very low, 1 Kelvin, but you calibrate it with 3 Kelvin, that result you cannot trust, because in the end it all goes back to the temperature sensor. Because the temperature sensor is not linear all the way. So the only valid range would be the range that you have tested. So in this example we've used 25% more and 25% less than 1 gram, but you can also check it with 30% more or less benzoic acid. And then you have your temperature window in which your sample has to be. If it's not,